Hello, this is how to get started with KXmlGui, which is a KDE framework, an important library from the KDE community for creating applications that use Qt widgets, graphical user interface applications that have the standard KDE main menu, the about boxes, the help menu item, etc. Let's see how we get here. kde.org, on the top menu, develop, and then tutorials, and then from tutorials, getting started, and then getting started with KXmlGui. So you can create graphical user interface applications using the KDE technologies, either using Qt Widgets or QML, Qt Quick Controls to Kirigami. So you should choose between Kirigami and Qt Widgets. We are choosing Qt Widgets right now. So KXmlGui is one of the many KDE frameworks. There are around 60 of them. And there's a hierarchy in which some KDE framework can use other KDE frameworks. So it's a tiered architecture. Let's start with a tutorial. We're going to create a Hello World program. We're going to use the KDE API KMessageBox. Let's see what KMessageBox is. Is it a function? Is it a class? So it seems to be a namespace named KMessageBox, for which you will include KMessageBox. And there are 3 functions for creating message boxes. Let's look a bit at the API reference site for KDE. This is the tiering of the KDE frameworks. The tier 0, which only depends on Qt, maybe not even that, is extra CMake modules. Then tier 1 only depends on Qt and some other non-Qt, non-KDE libraries, but very small dependencies. Internationalization for translation, Kirigami builds on top of Qt Quick Controls. Tier 2 can depend on other KDE frameworks, Tier 1. And then Tier 3 is everything else. Okay, and then using KRunner, which is the search box, which is Alt F2 in this case, we can get straight to the documentation. So KDE colon and KMessageBox. Not really. I'm running this tutorial on Kubuntu 2504, which has older versions of Qt, KDE frameworks, and KDE packages in general. We will need to use the KDE frameworks for this tutorial, more than one, and we're going to need to have the include header files. We're going to need to have the SO files of those dependencies, etc. So for this, we will need to install all of the needed dependencies, all of the KDE frameworks, and then their dependencies. All of the KDE frameworks that are required by this tutorial. One of the ways of doing this is by using kde-builder, which in my case is advantageous because kde-builder by default will build a KDE module, such as a KDE framework from source, from the Git master branch, and it will also build all of the other KDE Git repositories that are needed for the KDE Git repository that we wanted to build using kde-builder. So the KDE Git repositories, the needed ones, will be built in the correct order and from Git master branch, which is the newest and latest source code. I have set up kde-builder. So this is the build framework from KDE. The procedure is like this. You download a initial setup.sh file, you run it through bash, it will create a it will install kde-builder into ~/.local/share. It will create a symbolic link from the kde-builder executable, which is a Python file, towards ~/.local/bin. So ~/.local/bin needs to be in the path environment variable. Your operating system should have the directory ~/.local/bin pre-created and added to the path environment variable, even if it's empty. The directory ~/.local/bin on the Debian and Ubuntu family of Linux operating systems. If this directory exists, ~/.local/bin, you can just restart your computer and the path environment variable will contain this directory. Then you generate the configuration file for kde-builder. Since kde-builder is in ~/.local/bin and that's in the path environment variable, you can just run kd-builder without any relative paths. This will create the configuration file ~/config/kd-builder.yaml. Let's actually go to this file. Let's open a terminal. Okay, so let's look. These are default settings. We're using Qt KDE Frameworks version 6. If I want to build, for instance, KXmlGui, the KDE framework, all of the other KDE Git repositories that are needed by KXmlGui will be also Git cloned and built and installed. So ECM extra CMake modules, kconfig, k internationalization, etc. The Git cloning will take place in ~/kd/src, building and code generation in ~/kd/build, and then the equivalent of the make install step will take place in ~/kd/usr. I'm using the CMake build configuration debug because I actually want to run the build source code, the build artifacts by kde-builder inside an integrated development environments debugger integration, or in GDB, the GNU debugger. And then I have added 2 extra repositories. Let's remove them. With this, I should be extremely similar to the default version of this file. The only changes that I did was to change rel with debinfo with debug. I have added debuild Python bindings because I equals off because I do not want to build the Python bindings, so PySite 6 for some KDE Git repositories. Then I have installed the distro packages. So from your Linux operating system, all of the non-KDE packages that are needed by all of the KDE frameworks, etc., and other KDE Git repositories will be installed using the package manager. Then, as a final step in setting up kde-builder, you test it. You give it the name of a KDE Git repository to build it, including its dependencies. So let's see how that works. it downloads the metadata about KDE Git repository, so the data about dependencies between Git repositories, the branches to be used, etc. And then it computed that it will need to git clone 28 KDE Git repositories, git clones them in the correct order, builds them in the correct order, installs them in the correct order. So this command line has succeeded. KDE-builder kcalc. It has built kcalc and all of its dependencies, KDE Git repositories. And now we can run the build application. So that's KDE-builder -run kcalc. And that's it. The application launches correctly from ~/kde/usr directory where it was installed. Once we have KDE Builder, the build framework installed, we should start working at our tutorial, which is going to be named KXmlGui -tutorial. And we're going to use the Qt version that's being used by KDE Builder, and we're going to use the KDE libraries and frameworks that are installed into ~/kde/usr by KDE-builder. For that, our tutorial will also need to become a KDE Builder module. KDE Builder will need to know how to build it. The minimum integration that we need to do between our tutorial and KDE Builder is to edit the configuration file and append this part to the configuration file. Control End. Let's copy paste. So indentation is done with 2 spaces. Probably should be a trailing new line. So KXmlGui -tutorial repository nothing, which means don't do any git operations. Don't git clone, don't patch, don't anything. And no src also for this. We want KDE Builder to not do any source code changes in ~/kde/src/KXmlGui -tutorial. Okay, and we should also create this directory. Make dir -p, Ctrl V. If you're not using KDE Builder, there are other options to install all of the other dependencies of this tutorial, so KDE Frameworks. In the case of Linux operating systems in the family Fedora, Red Hat Enterprise Linux, and OpenSUSE, SUSE will need to also install packages with -devel name, RPM packages. In the case of the Linux operating system family, Debian and Ubuntu, you will also need to install the -dev packages to have all of the needed files such that you can build C++ source code from scratch. And this is how it looks like. For instance, on Fedora, you install some KDE frameworks and their -devel package. If you install the -devel package, also the non-devel RPM package will be installed as a dependency of the -devel package. Okay. Let's see what text editor we're going to use, probably multiple. So let's start with Visual Studio Code. All the code we need will be in one file. Okay, how do we do that? Let's create a file, main.cpp. Let's copy paste. Okay, so we're going to have a project that's using C++, which means that we're going to use the toolchain that I have installed on this computer, which is a version of GCC G++, the GNU C++ compiler. We're going to probably need to use a build system such as CMake, and we're going to use the Qt version that we're using in kde-builder, which is the one installed from my Linux operating system. So the Qt modules will be from /usr/lib and etc. So from /usr, whereas all of the KDE dependencies, all of the KDE projects have been built using kde-builder and are available in ~/kde/usr directory. Okay, so Q application is from a Qt framework module, and KMessageBox is from a KDE framework. This comes from /usr/include, and this one from ~/kde/usr/include. The entry point of the C++ executable int main is creating a Qt Q application, and then we're using question to actions from the KMessageBox namespace. So it's going to create a message box that's model, that's on top, and has two buttons, two actions, primary action and cancel. Doesn't have any parent window, has a text and a caption, a title. Okay, and as result, we'll see if the user has clicked on the primary action or on the cancel button. And then we'll return an exit status from our command line executable. Okay, this is defining a action. We're using KGUI item. This is the constructor of probably the class. And it has a text, hello, as you can see in the screenshot. And then there's also a tooltip that you will see if you hover on top of the button, of the first button. And then there's also a what's this. Or what's this? Maybe you need to press the shift key while the tooltip is being shown, or you might need to have inside the window title bar the what's this button. The what's this text or alternative to the tooltip is not so standard. It's not really used by many Windows applications, not used by any GTK or GNOME application as far as I know. So it's a mostly a Qt thing, and even I'm not even sure that people actually use this feature. So it's kind of like a hidden feature, an Easter egg, and should probably stop existing in my opinion. Okay, the other action is the KStandard-GUI item cancel. Let's look at the API. case message box is the namespace, and then question to actions, a function inside that namespace, static, and we have a parent Qt widget. This is usually the parent window. You have a normal window, and then this is a modal dialog, which should make it such that when you display the modal dialog, the other window, the main window, is not actionable. You cannot click on it. You will need to decide what you want to do with the modal dialog first, either close it or accept. Okay, so you have a text for the body, a title, and KGUI items for the first button and for the second button. And two default parameters. Don't ask again, string, and options notify. Okay. So we're not really running this application, but we're trying to add more source code to this application. It says that this text can be accessed by right-clicking on the button or Shift F1 key combination. I'm on the same tutorial page, but further along, because I want to make sure that even this first iteration of the Hello World application compiles and runs correctly. For that, we will need a cmakelist.txt file. So let's create the file cmakelist.txt, new file, Ctrl V. We're going to paste the content. And let's see what's in here. cmakelist.txt, the top level file, cmakelist.txt file should start with cmake minimum required, and it does. Then there's a name for the project, should not be named Hello World, but KXmlGui minus tutorial. It uses ECM extra CMake modules. It uses Qt 6 modules, core, and widgets. And it says for what. So from core, it wants Q command line parser and Q string literal. From widgets, needs Q application. But probably more things are needed from the Qt 6 modules, core, and widgets. From KDE Frameworks version 6, it requires Kcore add-ons, K internationalization, and K Widgets add-ons. K Widgets add-ons is the home for K message box. It will create an executable named Hello World that only has one translation unit, which is main.cpp. The executable will link with Qt Widgets, K Core add-ons, K internationalization, K Widgets add-ons. Maybe if you link with Q widgets, it's also going to link with the core. And then it's going to install Hello World in tilde/kd/usr/bin, and things should work. Hopefully they do. So let's see. Let's look at the configuration file again. So at the very end, we have a project KXmlGui minus tutorial. Let's see if we need to be in that directory when we build. So we don't specify For KXmlGui minus tutorial, there's no way for kde-builder to know which are the dependencies. We already built a number, maybe 20 KDE frameworks, when we built using kde-builder the graphical user interface application KCalc. So most of these modules are already built, but we'll need to build all of these just in case. The building is going to be fast, it's going to be incremental, so there's no problem with you running the same kde-builder command line multiple times. Let's see how many Git repositories in total are going to be git cloned and built. So 35 KDE Git repositories. Some of these are not from the KDE community, but the vast majority are from the KDE community. So Wayland is not from the KDE community. So it's building many KDE Git repositories, many KDE frameworks, and all of their KDE Git repository dependencies. Some of these, maybe 20 of these, have already been built. We're doing incremental build, so it will finish very quickly with that module, but then there's at least 10 which we did not build yet, so that will take a while to build. We're building using 16 CPU threads, CPU cores, CPU threads actually. And we have plenty of random access memory. Breeze icons is a special case. Even if we do build, so incremental build, not a full rebuild from scratch, which would be a clean and then a build, it still takes many seconds to figure out that Breeze icons did not change at all and nothing should be done for this module. So maybe a minute is spent on Breeze icons. That's why after I build Breeze icons, I ignore the module. So the syntax is in the configuration file /.config/kde-builder.yaml. In the global part of the file, at the end, I have ignore -project colon, -gpgme, -breeze, -icons, -qcoro. But you should build all of these modules at least once per week. If you have build failures on dependencies, modules that depend on these three, you should also build these three again. So you can build them by just commenting out this part. Okay, so it's going to take a couple more minutes to finish building. Then we want to build, so KDE-builder, KXmlGui -tutorial. Hopefully it finds the source code in the correct place, which is ~kd/src, and then this string, KXmlGui -tutorial. And then it knows how to build it because we're using CMake and we're using common KDE structure for the CMake lists.txt file, so kde-builder should know what to do, should know how to build and install. And at the end, similar to how we have built KCalc, so that was KDE-builder KCalc, then we have run the executable, the graphical user interface application, that was KDE-builder -run KCalc. But in this case, the module is named KXmlGui -tutorial, and the final executable is named Hello World. I'm not a fan of modules of Git repositories that have one name and then the only important executable that's being installed is named something totally different. So this should be important, this should be branding, this should be decided once and used everywhere. And hopefully should be KXmlGui minus tutorial instead of hello world. So we have run the command line that builds the KDE frameworks, KDE-builder, and then a list of KDE frameworks. Then we have built KXmlGui tutorial. Everything was successful. This is how building KXmlGui minus tutorial looks like. Doesn't do any git operations, finds the correct directory, ~kd/src KXmlGui minus tutorial. Can use CMake Ninja, can compile, and can install. Let's actually look at all of these directories. So first the source directory, ~kd/src KXml-GUI minus tutorial. There's the CMake list.txt file, this guy, and main.cpp, and then ECM extra CMake modules and the CMake building created this symlink file, compile _comments.json. There's a directory ~kd/build/KXmlGui minus tutorial where compiling, building, and code generation took place. There's the file prefix.sh, which sets some environment variables such that we can run KXmlGui minus tutorial from the correct place, which is ~kd/usr/bin with the correct environment variables set, and it will find the correct versions of the SO files of the KDE frameworks, which have been built at this step. Then there's a bin directory, and inside there's the only executable that's created by the CMake list.txt file, which is hello world. Let's run the executable by double-clicking on it. Shows a message box, cancel, and then exits. We can also run it from the command line. It's not on the path environment variable, this directory, so we need to use a full path or a relative path, so /hello world will work correctly. Okay, and then this executable has been copied to the install directory, which is ~kd/usr/bin, and the executable is hello world. This guy. We can also run it from here. Why does it run correctly from ~kd/bin/build KXmlGui minus tutorial/bin directory? Because as we can see inside the prefix.sh file, we're using our path, so the paths towards the KDE Frameworks.so files, and not only, are provided inside the executable. Otherwise, you would need to specify the directory where the KDE frameworks have been built and installed using the ld_library_path environment variable. So these environment variables are not needed because they are about man pages, and these are about QML. We're not using any configuration files, state files, etc. The only thing that's really relevant for us is this comment. We don't need LD library path because we are building with rpath. So in fact, this entire file is not strictly needed in order to run our executable. Sometimes we're lucky, we can just run the executable by double-clicking on it. Sometimes we need to first run whatever source this bash script file, and then we will be able to run the executable, which is named hello world. So that's why we can run the executable hello world, both from the build directory and also from the install directory. Okay, and this compile _commands JSON file from ~kd/src/KXmlGui minus tutorial points to was tilde/kd/build/KXmlGui -tutorial directory, which is this one. Okay, let's see if kde-builder can also run hello world correctly. What kde-builder -run does is it does two things. First, it sources a prefix.sh file. All prefix.sh files look like this, so it just sets some environment variables, including having appended to the path environment variable the tilde/kd/usr/bin directory, where kde-builder is installing binaries, executables, and shell libraries, etc. Okay, so we're at this step. Alternatively, if you don't want to use kde-builder, you can run cmake manually. We're not going to do that. We're going to use kde-builder. Okay, and then once we'll add additional features to the application, we'll be able to make use of built-in functionality from Qt and KDE, which will automatically implement additional command line parameters for hello world executable. So help version author license. Next up, I want to see if I can switch to a better IDE, integrated development environment, for editing the source code. Right now, I have used Visual Studio Code, but I don't have any plugins installed which are relevant inside Visual Studio Code. I don't have a plugin for CMake, for C++, for Qt, for anything else that would make my life easy inside the Visual Studio integrated development environment. So I'm just basically using Visual Studio Code for listing the files in the open directory, and then for syntax highlighting for some files. I can open them in Visual Studio Code and look at the syntax highlighting. But I want way more, and my go-to integrated development environment for Linux and Qt is the integrated development environment from the Qt framework, which is called Qt Creator. Let's see how we install that. Let's look at my notes. This is my user page on the KDE wiki. And in here I have instructions for how to install Qt Creator and how to load inside Qt Creator a project that was previously built using kde-builder. So our project KXmlGui -tutorial has been built correctly using kde-builder. And Qt Creator has support for opening kde-builder built projects. How I install it? It's available as a binary package, probably in your Linux operating system, but I am using the Qt Online installer, which is available on the official Qt Framework website, which is qt.io, because I want the latest and greatest version of Qt Creator. And sometimes I might also look at pre-release versions of Qt Creator. Of course, it's way more easy to install it using your package manager, because this requires that you have a Qt account, that you download an executable, make it executable, run it. This will start a graphical user interface wizard, And from there, you're going to select to have from the packages that Qt makes available for Linux AMD64 as binary downloads precompiled, you're going to select in there Qt Creator. After that, it's installing another graphical user interface application, this Qt Online installer, which is called the maintenance tool. Qt maintenance tool looks like this. Both the Qt maintenance tool and the Qt Online installer are wizards. Both require that you have an account for Qt.io. And they're similar, the two wizards, the Qt maintenance tool and the Qt Online installer. I want to add or remove components. Let's see what I have enabled in here. You can install various versions of Qt, including beta versions and additional packages such as Qt Web Engine. All of these are binaries, precompiled. These just get unarchived, uncompressed on your computer, and you're good to go. You don't need to compile anything. Especially Qt Web Engine is really complicated to build, taxing on your random access memory, CPU threads, etc. Okay, I have selected just Qt Creator, the version that's offered by the maintenance tool. That's it, nothing else. From time to time, you run the Qt maintenance tool to make sure that Qt Creator is up to date. So for this, you select the radio button value update components, next, and you just accept whatever it suggests here. Unfortunately, there are two different flows in here, one for selecting what packages you want to have installed on your computer, and the other one is for just updating the packages that you have already installed. It says that all of my packages that are installed are up to date, so I'm using the very latest released version of Qt Creator, the integrated development environment. Okay, let's see next. We already saw the configuration file for KDE-builder, where I have enabled the CMake build configuration debug, which is required by me because I am a heavy user of the debugger inside integrated development environments. But we can look again at the configuration file. So in here at CMake options, it says that CMake build type equals debug. We have built our application. We have built both KCalc as in this example, but also KXmlGui minus tutorial. And then it says that there's just one step, which is once Qt Creator is running, you go File, Open File or Project, and select the file cmake cache.txt from the build directory. So let's see that. File from the main menu, Open File or Project, and then we're going to paste the full path to the cmake cache.txt file. So inside the build directory, cmake cache.txt, I'm going to copy the full path, Ctrl-C, Ctrl-V, and open. You can also navigate in the file open dialog. It selects the correct option, which is debug imported, selects the correct build directory. We need to press configure project as it says in here. For modules that use QML or Qt plugins, etc., we really need to set the correct values for some environment variables using prefix.sh. But again, we're in a very special case where we can ignore all of these environment variables that are being set inside prefix.sh, so we can just skip over all of these steps. Okay, let's see what happened. Let's see the graphical user interface of Qt Creator. So this is the selector for modes or for tool windows. So this is the mode edit, which is Ctrl+2. If you switch to another mode, the main body of the application will look different inside Qt Creator. We're using edit. This is the CMake project view. It's called projects. You can select something else in this combo box. This is showing the structure that's defined inside CMake list.txt. So it's showing targets such as this executable. So this line 27, add underscore executable hello world, makes the Qt Creator edit mode CMake projects tool window 3 view show this node, which is called hello world and has this icon with the hammer, which means that it's buildable. Okay, we have source files, and this CMake list.txt depends on a ton of other CMake list.txt and other files with extensions CMake, etc. At least the following are being used. So ECM, we have built ECM because that's the very first module that gets built when you build any KDE module. So this one, frameworks extra CMake modules, installed in tilde/kde/share/ECM and in other places. There are the Qt CMake files for each Qt module. I have installed Qt using binary packages from my Linux operating system, which is Ubuntu 25.04. And apt installs deb packages, the contents of the packages to /usr. Okay, all of the KDE modules have been built and are available in tilde/kd/usr. Now we have, in addition to what we had, the features that we had working in Visual Studio Code, we have syntax highlighting for CMake list.txt. We don't need to install any plugins. We already had syntax highlighting for CPP files, but now we also have navigation to .h files, so to C and C++ include files. For most symbols, we can see that kMessageBox is a namespace. Unfortunately, the Qt Creator integrated development environment doesn't really use tabs for the list of opened files, so you must use this combo box. So this is the replacement of tabs. As you see in web browsers, there are tabs at the top. In here, these are available inside the combo box. And maybe because many people complained, there's also the tool window open documents available by default and visible by default, which shows the files that are opened currently in the integrated development environment. Control tabs file switcher works correctly, tab switcher. We can navigate CMake variables, other symbols. Okay, there's a ton of other features. Next up, so we were able to navigate files. We're able to see the outline of the available files. We're able to navigate some symbols, so code navigation. Next up is building. So for that, we will look at the configuration. So that's projects, switch to projects mode, Ctrl+5, this button. This is the tooltip, you need to wait a bit. Build and run this thing. Run settings. If you have more than one CMake target, then you might be able to select in here. We have just one, so nothing to select in here. We don't need to edit the environment variables, so nothing extra is needed. We can just use the bottom left buttons. Build, compile output Alt+4. Building is incremental, so it actually didn't need to do anything. Let's do a complete rebuild. So this thing from the main menu, build, and we have build project and then the name of the project. So this is the group box that we're interested in. So we have clean. We have run CMake. You can also run CMake and see if CMake can find all of the dependencies in exactly the same way as KDE-builder did. Okay, it complains that we're not yet under version control, and it's a very good idea to start being under version control as soon as possible. So we're in the directory tilde/kd/src KXmlGui tutorial. Let's initialize in here, git init in this directory. Let's look at, I'm using the built-in graphical user interface application that's provided by the Git project named git-GUI. This is the only tool that I have always used for graphical user interface over Git. Only this and this other one, which is called git-k. Okay, let's do an initial commit. The file cmakelist.txt is part of the source code and needs to go in version control. cmakelist.txt.user was created by Qt creator. It's specific per user, per computer, etc. should definitely not go to version control. Compile commands.json, the symlink has been created by KDE-builder by ECM, so it should not go to version control. By just rebuilding, this file will be recreated. And main.cpp we have manually created. It's the C++ source code, so should go to version control. Initial commit is always has the same git commit title, git commit message title, initial commit. Okay, and now we don't like that these two files are being shown as unstaged changes, which means that we might accidentally stage one of these changes, and we totally do not want. We want everything to be clean once we do a commit. We want 0 unstaged changes. For this, we need to use a git ignore file. So let's do that. I have started git GUI from a terminal, but without specifying the ampersand at the end, which means that this prompt is still being used by git GUI. Let's detach it, Ctrl+Z, background it, BG. And now I can work in the graphical user interface application, and my terminal is free to do its things. Okay, so let's create the file. How do we do that? Let's copy, well, not. Let's create a file. Okay, we can take inspiration from existing source code. So we can use, for instance, tilde/kd/src/kconfig. It also has a gitignore file. So let's compare the two. I'm using the graphical user interface difference viewer application named meld. I put the path to the two files, full paths. And probably I want this introduction line. And let's see what files we don't like and should be ignored. So cmake lists txt user, this thing. And compile commands JSON, this guy. What I'm doing is that I consider the .gitignore file from the project kconfig as the reference, as the source. Most .gitignore files for KDE projects should look very similar to this from kconfig. All should have this introductory line. All should have this order for lines and these values for lines. Even if you don't have all of the lines, your compile commands should always be ignored with a slash at the end. So only the top level compile commands.json file should be ignored. You're not ignoring cmake list.txt.user, but you're ignoring cmake list.txt.user asterisk, because that's what kconfig has decided. So we keep the order and we keep the exact values for the lines that we include. We don't include all lines, but for the lines that we include, they should be exactly the same. That's my way of doing it. Just rescan. The files will be ignored from now on. Where might be the name of the file or the name of a module, or where. This is the way I use Git commit message titles. Where space what, and what is add file. You should look up on how to create better Git commit messages, and the title should be short. Then there should be two new lines and then the body of the message. I rarely have bodies for messages because my Git commits are extremely short, extremely small. And you should not use past tenses, so not edit file, but add file. Commit. Let's actually rerun everything and make sure that these two lines have disappeared. So build this group box and then clean. Build and then run cmake. Unfortunately, we did not clear the general messages before. Okay, it keeps complaining that we're using git master branch and it doesn't have a remote. I'm not sure why it would care. Okay, we in here can see how the file tilde/kd/build/kxmlgui-tutorial/prefix.sh has been created. This file. And says like this: optional packages have been found, required packages have been found, and doesn't say anything about optional packages. We don't have that. And it doesn't say provide any error, doesn't say that a package has not been found, which means that cmake configure step has run correctly, and it has generated some files into tilde/kd/build/kxmlGui-tutorial. We can even delete this directory and see how it gets recreated. Build clean and build build run cmake. Okay, the directory has been created. Wow, that was not a good idea. So don't delete the entire build directory KXmlGui tutorial. Let's do everything from scratch. So we're going to delete the build directory because the Qt Creator integration depends on the fact that we have built the module using KDE-builder successfully previously. So let's do that. We need to run kde-builder KXmlGui tutorial. It's not showing Git errors anymore. It's successful and it has created the directory correctly because we depend on the cmake cache.txt file. That's how the integration works. This file needs to exist before we open it in Qt Creator. So we select the file, Ctrl-Alt-C, Ctrl-V. Okay. And now we can open the project. The cmake configure step has been run again by Qt Creator just automatically when we opened the cmake project. And now we can build. Building doesn't do anything because it's incremental, and at this step building was successful. And now we can just run it. We can run with debugger or without a debugger. In this button in the left bar of Qt Creator, we can see what's going to happen. So we have the project Hello World loaded with the correct build configuration, and the Hello World executable is going to be run when I press any of these two buttons. Okay, so running from Qt Creator worked correctly. Let's see if debugging works correctly. We can test it like this from Qt Creator main menu, debug, start and break on main. So it saw if building was necessary. So it does incremental build. That was extremely fast. And then it has found the correct executable. So we want to debug the cmake executable target hello world. It found the executable, which is this file. It has started this executable inside the GDB debugger or something extremely similar. So the debugger is pre-attached to the executable. And then it has looked inside the executables, exported C++ symbols, found in there the entry point of the application, which is the C style exported function in main. And it has stopped the debugger immediately after entering the body of the main function. This is the usual C++ debugger experience that you get from other tools such as Microsoft's Visual Studio, not Visual Studio Code. You have a view with locals. You have the call stack, which are the functions inside the current thread that we're in. You have the list of all threads, list of all breakpoints. You can delete breakpoints. Unfortunately, it also shows breakpoints from projects that you have opened 1 year ago, so you should clean breakpoints from time to time. There's support for inspecting an identifier if you hover on top of it. So app is local variable that hasn't been initialized yet. And now if you hover on top of it, it shows something more adequate. Okay. And you can step into and step over. The buttons can be seen here in the debugger tool window. There's stop, continue till the next breakpoint or till the next error, step over, step into, step out. The same are available from the main menu debug item. F5 to continue, F10 step over, F11 step into, and step out shift F11. Okay, so let's see if we can step into the constructor of QString_literal probably. You don't really know what GCC or what the executable is going to do when you press the step into button. Anything could happen. So step into is a lottery. So inside the Q make string private. For what reason? I have no clue. Because I'm not sure. The Qt libraries have been installed using deb packages from Ubuntu 25.4, which means that I do not have the CPP files, the source code for the Qt framework. I have the include files, the .h files inside /usr/include. I don't have the source files, the CPP files. And I have the binaries, the .so files, which are going to be ingested by GDB, the GNU debugger. I don't actually also have debug symbols for anything that's installed from Ubuntu. So I don't have debug symbols for the Qt libraries. But for the KDE libraries, which get installed in tilde/kde/usr, I have both the source code and the include files and the SO files and the debug symbols. The debug symbols have actually not even been stripped out of the .so files. You can try to step out with Shift F11. Shift F11 doesn't work correctly always. It did in this case. F11. So I really want to get straight to the constructor of QString_literal, or what's this line 14. We're still not there. This is an explicit QString. So this is a constructor. Okay, so there's nothing between main and the QString constructor, which tells me that probably QString_literal is a macro. And it is. So it's a C++ macro, which expands to QString constructor of this thing, which is, I don't know, a static method. Static free function inside a namespace, and it uses C++ templates. That's why we cannot see it in the stack. way more threads. So there was just one thread at line 5, but then once we started, we created Qt application, we have a ton of other threads created by Qt. For dbus, for X11, for, I don't know, GPU, hardware acceleration, or software in this case acceleration. Okay, let's step inside the constructor of KGUI item. So F11, Shift F11, Shift F11, F11, Shift F11, Shift F11, 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 F11. Ooh, so it took an entire dance of stepping into and stepping out to get to where I wanted, which is the constructor. So I wanted to debug, to have the debugger paused inside the C++ source code that's inside the body of the constructor of the KGUI item class. So inside where? Inside the constructor with 1, 2, 3, 4 parameters. You can expand this combo box, which shows all of the symbols available in the current file, to go to the constructor with 4 parameters. So it's a QString and a QString icon. There's the back icon. So QString, only QStrings. Forward. The combo box with symbols, so QString, this guy. This is how you get to the .h file that contains the definition of the constructor for KGUI item class that takes 4 QStrings. And it's going to find them where it was installed, tilde/kd/usr/include. So this navigation is made possible by Qt Creator. Whereas the other navigation that we did was using GDB, the debugger, which has navigated to the source code of the constructor, to the CPP files. So this is the actual body of the constructor. The only way that I know how to navigate to this place is either you use the debugger and carefully step into and step out of a ton of times, or what you can do is, besides this project, Hello World, you can also add the project that contains this source code file. So let's see what that would be. How do we find out? So it's K-Widgets add-ons, a KDE framework, and a KDE Git repository. So that would be like this. Load project. And we need K-Widgets add-ons. Okay, so for this we need the file tilde/kde/build/kwidgets add-ons /cmakecache.txt. And then configure. And now we have two two Git repositories, two projects, two CMake projects available inside Qt Creator. Previously, it complained that the file KGUI item.cpp is not part of any project recognized by Qt Creator, and now it did recognize the KGUI item.cpp file. It's inside the KWidgets add-ons module, and it's navigating in the tree view with CMake projects correctly to this item, KGUI item.cpp. The CMake target is KF6 widgets add-ons, which actually generates a .so file. This guy, bin/lib kf6 widgets add-ons.so. Okay, we don't really need this thing, so let's remove the project. How do we close project? Close project, kwidgets add-ons. Okay, back to where we were. So I prefer Qt Creator because out of the box, without installing any additional plugins, supports all that I could ask from a Qt C++ integrated development environment. So opening files, syntax highlighting, code navigation, seeing all of the symbols that exist inside the file, CMake configure step, build, run, and debugger. And I use the debugger a lot. Okay, with that, we should be back to our tutorial. So now that we have the first iteration of the project, which is this first version, so the first version for the file main.cpp, we have it under version control in Git. We could run it by double clicking on this executable in two places, in tilde/kd/usr/bin, in tilde/kd/build/KXmlGui -tutorial/bin. We could run it using KDE-builder -run. We could compile it correctly using KDE Builder and using Qt Creator. We could run it and debug it in Qt Creator. So that's the milestone that we are currently at. And we also have way better code navigation. Okay, so the tutorial goes through the source code of the first version of main.cpp file. Okay, so we're using kmessagebbox, which is a .h file, which is also a namespace, C++ namespace. It's a member of the KDE framework named KWidgets add-ons, which is a .so file. There's a free function named question to actions. There is documentation, docstrings, before the declaration of the function, as it should be, because it's a public symbol exported from a .so file, so it should have documentation inside the .h file. Okay, so this is the documentation. Let's see what it does. So there's a parent, a text, a title, two actions, and two optional parameters that we're not providing. Let's see a bit why was there a need for KGUI item. On Windows, a similar API is called messagebox, which receives as parameters a parent. If you put null ptr 0 in here, it's not going to be parent, not going to be modal. There's a parameter for title, a parameter for the body, and then the type of message box. So In this case, if you have two buttons, a yes and a no, that would be MB yes no. But in here, there's a more complicated version where not only that you receive the fact that the yes or no, the no button has been pressed when the function returns, you also have the opportunity to completely control the buttons. So you control the appearance of the buttons, the text of the button, the tooltip of the button, what's this text of the button, what's going to happen when the user clicks on the button. And then because you control what happens when the user clicks on the button, you're going to be able to have your own functionality running when this button is clicked. Or not. So I see enabled. This is how in C++ the Qt framework does the equivalent of C# properties. There's a is enabled and a set enabled. One returns bool and the other receives a parameter of type bool. Set what's this and what's this. Set tooltip and tooltip. Set icon name and icon name. So the getter is without any prefix, just icon name. The setter has the prefix set icon name. So these two C++ methods work as a Python property or as a C# property. Okay, the enabled property uses a different syntax. So set as usual for setters, and the getter has the prefix is. Okay, set text and text, the property text. Set icon, icon. I don't see any way where you can specify the action that's going to happen when this KGUI item is triggered, so a callback or something similar, an implementation of an event in C#. Okay, we can close open tabs in multiple ways. You can go right-click on it and close. I can find the button close KGUI item. You can close it in here, Ctrl W, by clicking on this button in the toolbar, or you can close it from here. It's the currently selected file in the tool window open documents, so you just click the close button for the selected item. Okay, so actions are about appearance. We have a custom primary action, so one that we have defined before. This local variable is being used here. And then as the second action, there are some KGUI items that are pre-configured for us. Let's look at KStandardGUI item cancel. So it's still from, where is it? KStandardGUI item and cancel. So I'm not sure why, but it didn't navigate correctly when I clicked on cancel. But now it does. Okay, so let's see what this cancel is. So cancel returns a GUI item. It's part of a namespace, so it's a free function. This is the .h file, so we don't know exactly what the body of cancel does. Let's actually find out. So kf6, kwidgets add-ons. We can do this multiple ways. We can step into with a debugger. We can add kwidgets add-ons to the projects view. We can just use whatever grepping tool we use. Let's do it first with the grepping tool. So we want the .cpp file that contains the body of this free function. So that's in kwidgets add-ons. So tilde KDE src kwidgets add-ons. Open in Visual Studio Code, for instance, for grepping. Ctrl-Shift-F. Close. Match case and match whole word. Okay. And we're going to ignore files that are not useful for us. So files that are not CPP. Let's see how we do that. We could either include, so go asterisk.cpp, or we could exclude. We can exclude all of the files from the directory poqm. And what else? We can exclude .h files. H. Okay, so what, comma, what? We want to exclude the entire directory poqm slash, and then you can go just .h, or you can probably go with the glob asterisk.h. So this is a substring in the full path. So not only in the name of the file, but also in the name of the directory that contains that file. Okay, so kstandard GUI item.cpp. CPP part, the source code of this symbol is here. So it's constructing a object using class KGUI item, the constructor with many strings, many Q strings. It's going to use a translation mechanism and library. It's not using K-internationalization, but it's using the built-in internationalization translation framework from Qt. So in the KDE project, we use two different frameworks for translating a string from English to, I don't know, German. The first one would be what's built into Qt, and the other one is the K internationalization library. Okay, so says from where, K standard GUI item, what. So this string should be translated in the language of my application. The accelerator let's see if the accelerator works. How do we do that? Debug, stop, run it without debugger. And the accelerators are not visible by default because of this Qt Widgets theme, which is a default theme in Qt Plasma. in KDE Plasma. If we press the Alt key, we can see the accelerator appearing. So with Alt key pressed, we can see that pressing C will close the dialog. Hello doesn't have an accelerator. We can add an accelerator for Hello just to make sure everything works correctly. So this string should have a accelerator before H. We can just run it and it will compile correctly. Always save before build. Save. And now if we press the Alt key, there's accelerators underneath H and C. One coming from here and the other one coming from here. Then it's saying the icon that should be used for our custom action, no icon. For the predefined KStandard-GUI item cancel, the icon should be window minus close. This icon is being picked from the current icon theme. So depending on your operating system, on the desktop environment that you're running, a different icon theme might be used. For instance, on Windows, if you're not including the KDE default icon theme, some icons will be provided by the Qt framework, both from Qt framework resources and also from the operating system Windows. The continuator operating system for BOS, the open source operating system Haiku, has a very specific BOS-like icon theme. Okay, and then we have another string translated, which is the tooltip. Okay, so this was body text of the button. This is the icon. This is a tooltip, and we're not providing what's this, which is again for the better. We should just delete this part. Okay. Let's see what question to actions returns. Because we're using auto, we don't really exactly know what's returning. Type alias auto button types. So maybe the type is button code, and this is the doc strings not in the best presentation possible. Yeah, so the doc strings that are being used by this KDE framework don't work correctly inside the Qt Creator tooltips. Something seems to be wrong with \A. \A being the documentation for a parameter. Let's see if that works okay for Qt symbols. No, we don't have at all doc strings for this constructor. That's very, very interesting. Why would the documentation strings be missing from a .h file? From such an important library such as the Qt 6 modules. Okay. I don't know. It certainly looks like a bug to me. So the doc string should be here when I hover, should be available, and they should be part of the .h file. and they should be in English only. If you want other languages, then you should not use integrated development and tooltip. You should use a documentation browser or a PDF file that's translated doc strings extracted from that library, generated as PDF, and translated it into your language. Okay, so again, what the question was, what question to actions returns, and indeed it returns a button code. Let's see what button code is. Button code is surprisingly not coming from Qt Framework, but from KDE, from inside the same kmessageblock.h file. OK, cancel, primary action, secondary action, and continue. Okay. Let's run with the debugger and see what happens if I just close the directory with the message box without touching any of the buttons. Let's remove the breakpoint. Again, it remembers all of the breakpoints that you have ever set. So you need to manually delete them all. If you just unload the project, it will not remove the breakpoints from that project. We want to continue till the next breakpoint. So continue GDB for hello world. And now let's see. So if we click on hello, the returned value is first message box, primary action, correct. First button, primary action. Let's run it again. Click on cancel. And now it returns secondary action, correct. But what if we close by using the close button? It returns secondary action and not what I expected, which is cancel. That's very interesting. Okay, and you can also close the dialog by using shortcuts, the simplest of them being Alt F4. And it's going to return 4 secondary action, and it does. Okay, you can see in these hints that you see in line inside the text editor. You can also hover on top of the symbol. It shows the enum with the integer version and also with the human readable version, kmessageblock button code. Unfortunately, this source code wants to support very old versions of code. So this is a library. It's important to keep its stability. So replacing enum with enum class or enum struct is the future and is better, but then keeping it as it was for the last years makes it such that the ABI application binary interface and API application programming interface doesn't change, and that's very important for all of the KDE frameworks. There should be as much API stability as possible during the KDE Frameworks 6 lifecycle. So for as long as the KDE frameworks keep using the Qt 6 version. Once the Qt 7 version is released and KDE frameworks will stop using Qt 6 and use Qt 7, then API breaking changes might be possible. Okay. Let's see what's next. Back to main.cpp. Let's stop the debugger. We went over this single page of source code, the initial version of Windows CPP, a number of times, and everything should be relatively obvious. We're using Qt, and Qt using its own types of C++ strings. There's QString literal, QString constructor, QLatin1 string. There's the C++ literal string prefixes, many other ways of creating finally QString values. So values of this type that has this API. Control W twice. Okay, there's internationalization inside at least this guy. We have exit statuses. Let's see the values of exit status. I'm going to guess that exit success is 0 because that's the only successful exit status for executables on all operating systems. Exit success 0, standard library. /usr/include/stdlib.h. which is part of the GNU-C library, so glibc. Okay, let's do the next iteration. This note is not that easy to read. Says that using a QString literal constructor is a best practice in Qt programming. Well, it's a best practice to use Qt strings instead of the alternative would be UTF-8 string literals, or what? What would the alternative be? 7-bit string literals in C++. An unexpected coding practice in KDE software. So I'm not exactly sure what this thing is, but I see that it as internationalization, so maybe it hints that you don't want to ever show naked strings, not translated strings in your graphical user interface elements. So a button, the text of the button, you should make it internationalizable and translatable from the start. And this is what the next iteration does. It's using klocalized string to translate all of those strings. Okay, so in this example, primary action instead of hello now becomes this thing. Okay, so it's actually translating into my language, which might be German, this English text. Let's see how we make that work. Let's see if it runs. And it works okay. Behind the scenes, a ton of things are happening. There's translation catalogs, there's GNU getText, there's an entire library from the KDE Frameworks named K internationalization KI18N with the number 18 there. Okay, let's do all of the changes one by one. So first of all, it replaces all constructors of QString literals macros with internationalization. How do we do that? Control H, Control R. I don't know the shortcuts. Okay, so we did this part. And now we're done with the internationalization, except this part, which is very important. When we're translating a string, it's very important to be extremely precise, to say this is the English text, $hello, but take the translation, if possible, from this application, from KXmlGui minus tutorial. Take it from this environment. Where was it? In this case, for the close string, take it from this environment, from a context of a K-standard GUI item. And then you also have instructions for the translators, where you say the text that's going to follow and you need to translate into German is actually a verb, not a subject. Is actually a message box button and should be capitalized as such. Is not a a status bar text, so it should be capitalized as button capitalization, whatever is that for your operating system, instead of, and your language, and should not be capitalized as a sentence. So should not use sentence capitalization. So all sorts of hints are going to be provided towards the translators, and all of this helps making the translations as correct as possible. And some of the strings are really, really hard to translate, which strings that will have different versions for singular and plural and all sorts of that natures, things of that nature. Okay. We did the internationalization. Now we're going to do k-about-data. Most KDE applications use k-about-data. This is providing a number of common command line parameters to executables. This -help, -version, -author, -license. And it also provides support for this functionality. Main menu, help, about application name. So the components are going to be defined in k-about-data authors in there, thanks to etc. These URLs. Okay. And for that, we're going to add these two blobs, 3 lines. Let's fix the errors. Let's see if it knows how to fix this error. Probably not. Okay, we need the k-about-data symbol. That's from the an include file. And then we need the string literal prefix u and postfix -_s. And we do that with this line 8. Okay, and now everything compiles correctly. So the second part, the final part remained the same. We are using internationalization everywhere. And we have added a huge block because the about data is very complicated. So you can think of it as a huge JSON or XML document. What's being shown in here. So the name of the application, the version, the license, components, authors, thanks to authors have email addresses, have name and title. So all of this information that you see visible here, you can think of it as a huge XML document, and that's going to be fed to KAboutData using the constructor, using add-author, etc. And at the end, you attach the local variable about data that you created to the application. Actually, to the Q application in this case, so to app. Let's see how that works. So Kcore add-ons, set application data. Should be in a CPP file. And should be the body of the function. KAboutData.cpp should be the name of the file. So if the parameter is valid, it finds the something, gets the app, there's a singleton, and it sets various values for the Qt type app. Okay, so the various values that are injected inside the Q application and then can be retrieved when you run the command line parameters. The program name, the display name, the subtitle as it were, the version, short description of what the application does. So this is maybe the name of the executable, whereas this is the application name that's going to be displayed in here. And then this is the subtitle is going to be the description, this guy, short description. I do not know exactly. Okay, the license that you're using, copyright, etc. The home page, the bug tracker URL. This is metadata about an application. This has been done before, so in Q application, in KAboutData, in upstream meta info, in the description of Android applications manifest, in Snap applications, in multiple other places. Okay, so some data is set for the local variable about data, and then an additional author is being added. You can see that there are applications with hundreds of authors, hundreds of components, etc. Hundreds of thanks to. Okay, and then you're taking this local variable, setting it to both Q application and KAboutData. There's a static in there probably. And then when needed, that data is being fetched and displayed. Let's see what the documentation says about the command line parameters. So it says that where is it? Let's run all of these. How are we going to run them? From the build directory. cd:/kd build KXmlGui tutorial bin. Oof. Yes, they're not part of the environment variable path, so you need to prefix all of these. It actually starts the application, because the application starts doesn't matter the command line parameters that we're going to use. We have not edited the command line parsing. Okay, so we cannot actually run these command lines. There's not enough functionality for the K about data to work correctly. We're going to need a Q command line parser. Okay, let's see what it says. So it describes all of the changes. It runs the application such that we can see how it looks like now. The exact same that it was before. About data is not surfaced anywhere for now. Okay, and the last thing that we want to look at are the prefix u and _s. So this is a C++ string literal, also a C programming language string literal. It works correctly as a 7-bit ASCII list of characters. Function operator _s, part of QString provided by QCore application. Returns QString. Oh. Operator empty string _s. Let's see that. So in QString.h, something extremely magic. Namespace Qt, namespace literals, namespace string literals, operator empty string _s. This is not a corrected definition. How can it be? So this is u, and u is what? So there exists in C++ string literals and character literals either no prefix or u8 or l or lowercase u, uppercase u. UCS2, UTF-16, UTF-32, Wow. And the type differs depending on the prefix. So lowercase u is UTF-16. Really UTF-16, not UCS2. Who knows? Uppercase U is char32, so 32-bit encoded character. S suffix to generate a std string. stdw string, stdu16 string, u32 string. Oh. And roll string literals. Multi-character literals. What is this thing? So ABCD, but with single quotes, is not a string, but it's an integer. Changes in in C++ standard version starting from 14 and newer. Okay, and this strange one is the L, uppercase L prefix, which might differ depending on platform. Who knows? And what's WCHART? On Windows, it might be a built-in or a define. So UCS2 is what? Narrow single byte or multi-byte. U8. So U8 is MBCS or what? Or 7-bit. And then UTF-8 is what? Uppercase L? I don't know. Okay, so as we saw, the application's look did not change. We only added support for the future steps of the tutorial. And we're also starting the graphical interface application each and every time. Even if we pass the command line parameter --help, instead of showing the help message and exiting the application, instead it doesn't parse the command line parameter -help, doesn't do anything, and it shows the graphical user interface, the message box, as usual. So instead of using qstring literal, you can use operator empty string _s. Instead of qstring literal, you can type _u hello world. So u being 16-bit, UTF-16 encoding. Okay, so always when you use the prefix _s, you need to, the postfix, you need to use the prefix lowercase u. Okay, and now it's adding the support for those command line parameters. message box actually displays the message box, this question to actions. Okay, but now it should do additional functionality before showing the message box. So let's see what this new functionality is. We need a Q command line parser include.h file from /usr/include. To care about data, we set the parser. To parser, we set the Q application. And then we say about data process command line. Let's see what this does. So there's a command line parser, and this has methods for parsing the individual parameters. So says that if --license is provided, then it's going to printf all of the licenses in a for each. So this is a for each, for and then colon. If --author, then if there are authors, then inside the for each, go through all of the author list and append the email address and print the email address and the person name. Okay. Let's see all of this in action. Version and author. We didn't build yet. A translation unit hasn't been compiled yet, has changes in it, and was compiled linked. The executable has been created again. And now hello world --version returns the name of the product, the executable, and then the version. Okay, and then there's author that says John Doe, and if there, like this. If the bug address is not empty, then says please use please report bugs, or please use bugs.kde.org to report bugs. Okay. And where does this text come from? Hello world was written by. Hello world, the name of the application, %1 was written by, and then inside the for each, 4 spaces, name, space, and less than, email address, and then greater than. Correct. Okay, so we did version and author, but there's also help and license. Let's see those. Displays a KMessage box pop-up, and just the command line parameters that are implemented by the libraries that we use, by Qt and by kbouttdata. So --help, short version -h, --version, short version -v, author, license. So the last one that's remaining is license. And the license is the GPL. And it prints the entire text of the GPL version 2. Where did we specify version 2? In here. So GPL v2 is the same thing as GPL and is integer 1 in the enum license key. License key, well, that's a really bad name for an enum. License key is associated with license keys, so with serial numbers. So should be license type. Or license, I don't know, kind or something. Okay. And this is it. It's about time. How do we save? Or nothing to save. Okay. It's about time we did a git commit. How do we do that? Let's see if there's a terminal in here. There is. So the button terminal expands the tool window terminal, so the button at the bottom. And in here we can run git GUI. So 2 more iterations. I should have done an intermediate commit. As I changed main.cpp, I should have a different commit. So where, what, add internationalization, about data, and command line parser. And somehow the command line parser actually stops the execution of the program, doesn't show the message box. So it parses the command line, does what we wanted, which is do the -help output, and then it doesn't show the message box. So the execution ends before line 57. Let's see how we do that inside the debugger. So projects, run, correct executable, and command line arguments --help. And maybe run in terminal. And debug. Process exited with exit code 0, but where? On line 53, on line 54. Parser process the app. So this one probably does the thing. Let's find where it exits the entire process. We're not allowed to go there. Yeah, that's because parser is a symbol from a Qt library. Qt libraries come without debug symbols, so the debug symbols have been stripped out of the .so files. And they also come without CPP. files, so without source code, so there's nowhere to step into. But it's going to probably do, I know, the exit glibc API function to exit the entire process with exit status success 0. Okay. Let's see what's next. Creating the main window. From here on, we should advance way faster. So we saw the very basics, how to use a debugger, how to step into, how to see the documentation of symbols, where the symbols are defined in .h files, where is the body of the methods in .cpp files, which are available in tilde/kd/src, but are not available in /usr. How enums work, I know, how constructors, how toStrings work with string literals. KXmlGui window. If the source code is called KXmlGui window, the class should be called KXmlGui window. No, it's main window. Okay, that's better. So this is the function that we get from a KDE library, from a KDE framework, and this is our class. So let's see how that is done. We need to create 2 files. I have no clue how to create files. Like how? Maybe like this. Add new .h, choose next, add to version control. What do you mean add to version control? Add to project. Okay, let's see if it added it to project correctly. Let's look at the documentation for that. Where is the terminal? So add executable hello world and main window.h sounds okay. We didn't commit yet. Wow. Okay, main window.h. Let's copy the entire body. Main window.cpp. Okay, and let's fix all of the compilation errors. So what are the actual issues here? Says KXmlGui window file not found. Let's see if we depend on widgets add-ons. Seems to be okay. Ktext edit, where does that come from? I don't know. From main.cpp at the end. So there's including with less than greater than, which means files from outside of the current project, and then include with double quotes for the files inside the project. Okay, let's see how the application changes. Everything changes in here. Instead of tutorial 1, it's main window. Instead of hello world, there's main window. The strings, the comments have disappeared. Add author, so way less comments. About data, set application data. Q command line parser, this block stays the same. About data setup command line, parser process, about data process command line. And then we're not using message boxes any longer, we're actually starting a main loop. Okay, so main window, new window, window show, up exec, and let's fix the rest of the k about data. So this is main window, main window again. Version 1.0, a simple text area. Educational application. The rest remains the same. And the cmake list.txt gets extended. Okay, so a different executable probably. From Qt we only use core and widgets. From KDE Frameworks version 6 we also use text widgets and XmlGui. So one is this guy, KXmlGui, and the other one is text widgets for KTextEdit. Different executable. It's a good idea to add the .h files to the cmake lists.txt file. Let's just add this part. Okay, main window. Linking Qt Widgets, K-Core add-ons, K-internationalization, KXmlGui, and text widgets instead of widgets add-ons. Okay, so the difference is viewer is not that great. Should have highlighted these lines, 40 and 41. not 39 and 40. Okay, install targets, main window. This has also changed. What? All include quiet packages. It looks like English, this sentence. Okay, this should be it. Let's see if it works correctly. First of all, CMake configure. Text widgets could be found. XmlGui could be found. Then compiler output. Let's build. So it builds the translation unit, compiles the translation unit main window.cpp. That required code generation because we're using mock. And then finally it's doing linking of the four .o files. There's main window.o, main.o, and the mock.o3. Okay, and now we can run. No executable specified, okay. For that, we need to see if in here main window is selected and run it. And let's look at the extra settings. So projects, run configuration, build and run configuration main window. That's the only thing that should be available. And no command line argument and no running terminal, correct. Okay, and now we have a text editor. Okay, and because we have about data and we have KXmlGui, we get the main menu by default. And that means about the application. So we have one author, and the components are not part of a about data. They're computed by this dialog. This dialog takes the authors from the list of authors in KAboutData. Okay, about data takes the version 1.0, the human readable version name of the application, the other descriptions, copyright, license key, and application homepage. And we also get editors and toolbars and everything. No possible toolbars yet. These are all of the actions that are predefined for us. Was this show status bar, which actually hides the status bar. Is it? Oof. Settings show status bar. Keyboard shortcuts for the available actions. So actions have a title, such as whatever, a text, find action, have an icon, have a shortcut, might have an accelerator, might appear in the main menu, might appear in the find action, Ctrl-Alt-I, might appear in the toolbar. in the main toolbars. Rich context menu coming from the text editor control. So the Qt widget created by the KDE community, which comes from here. KText widgets, and is being displayed. In here. So a new KText edit is being created, centered to the widget, the window. And that member, the text area, is available as a private member, such that you can work on it from main window.cpp, maybe from the constructor, or maybe from an event implementation. Okay, if you switch to the projects view, this is the CMake project view of the project. If you don't have the .h files included in the CMake list.txt, they will not appear in here, and that's going to make them harder to navigate. So it's good that it forces you to also add all of the .h files. And now you have these header files, item in the tree view, projects view, and main window.h. You can also navigate from .h to CPP if you find the button for that. Switch header source F4. Okay, let's go to the constructor, the definition of the constructor of KTextEdit. Inside the .h file, tilde/kd/usr/include. From the library KTextWidgets. Set central widget is a method of this. And comes from Q main window. This guy. And that means that KXmlGui window inherits from main window. Yes, through K main window. This is graphical user interface, object-oriented programming. There's a hierarchy of classes. From various classes in your hierarchy, from various ancestors, you get additional methods for this, for the current object. And it's customary to pass to most Qt widgets in the constructor the parent. For instance, when you're creating a button, you will put the window as a parent. This makes it such that when you close the application will know that it has windows, it will close the windows. The window will know that it has a button, it will close the button. Free the button. Destroy the button. Okay, we're at this point where we must do a git commit. Terminal. So we have added main window.h. with constructor with parent, and we have the text editor as a private member, a field, data member. We have changed a bit the about data because now we're not tutorial number 1 or hello world, we're now main window. Also, the name of the executable has changed. It's now main window. And we can see that in our application. So tilde/kd/build/KXmlGui tutorial bin. This one, main window. Hello world has a older timestamp and we can delete it because it's not going to be regenerated. We scan. Omit. Next up, actions. If we want to create a clear action, can be done with the Qt API Q action. And the documentation does not work for some reason. And this is the exact same URL. Doc Qt.io Qt6 Q action. So now it's lowercase and with a .html. This is a good way of contributing to the KDE community by going regularly through the KDE websites, the KDE documentation, the KDE wiki pages, and making sure that all of the URLs continue to work. Of course, this is easy to actually automate. You can, for instance, download the entire website develop.kde.org, not the source code of behind this website, but the actual website using, for instance, I know, htdig. We'll download the entire website. And then for all of the HTML pages in the downloaded website, you're looking for the HTML element A, patch the URL in there, and just make sure that you don't get 404 when you wget that URL or curl that URL. So it's easy to automate even using just bash scripts. But this would be better implemented in the Python programming language. Okay, so let's see what a Q action is. We already looked at Q actions. So there's an icon. A tooltip, what's this? A text. These are properties, so pairs of set status, stat, tooltip, and tooltip. But then there's also additional functions that I didn't see before. Maybe these methods get inherited into the default GUI buttons that we have looked previously for the to action message box. Okay. But in here we can also see additional things that I was looking for. So separator is visible. The font for the text. Submenu shortcut. So not just accelerator, but actual shortcut. So Control K, for instance, would be a shortcut, and then the accelerator is the underlined icon that you can trigger with probably, I know, Alt and that icon and that character. So if underline this letter S by pressing Alt S key combination, probably the action is being triggered. Okay, so this is an abstraction for elements that you will see both in toolbars and in menus and in context menus. So used in Q menus, Q menu bar, Q toolbar. Okay, so let's change everything drastically. Main.cpp. We now have a new file which is an RC file. Set application domain KTextator, so the name of the executable has changed. Main window.h. We have a setup actions private method. And the changes inside the main window.cpp file are too much to edit. Too many. Okay, copy paste does not work. It adds random new lines in here. So this is probably something related to \r\n versus \n. So Windows style new line terminators versus non-Windows style new line terminators. So this makes you do dances like this. Down arrow key delete a million times. Okay. Let's first try to make this thing compile and then we'll look at the description. So this is documenting what has changed especially in main window.cpp. And we have a text editor UI.rc file. So this is a resource file. It's an XML, gets converted to C++ source code by the Qt executable named RCC, resource compiler. So it's an executable, takes files with extension .rc containing an XML in a special format, generating .o files. So think of it as a C++ translation unit. Copy. Again, I don't know how to do this. Add new. Let's see in here if there's no search edit box in here. We want a Qt resource file, not a QRC. How do we do just the RC file? I'll do a QRC and then I'll rename it. So this is another type of so this is actually the input for RCC, whereas these RC files are just for configuring KXmlGui. Okay, copy the entire file, Ctrl S. And we must integrate everything in CMake. So the only change that actually happened in the number of files that we have is that this file has been added. So let's make it available in CMake list.txt. Let's see how we do that. Ktext widgets. Now we also need kconfig widgets. Text editor. We have added this one, main window.h, and it's a good addition. Text editor. Config widgets. So this is for the linker, the target link libraries. So text editor, and then KXmlGui. And this should be it. Everything should work right now. File, save all. Let's make sure it builds. What do we do for that? So kconfig widgets has been added. Once we save the CMake list.txt file, the CMake configure step has been run. I see everything be correctly and found, which means that we can build. We can even switch back to the CMake projects viewer. The executable is now named text editor. There's also the RC file, which should be surfaced somehow inside the tree view by being added, I don't know, probably here. And we're going to need to change a bit the project definition. So build and run. The configuration is text editor. Let's go to this and remove it. Yes. Okay, so maybe this changes automatically if you don't have customized targets. So if you are not working in here, in this combo box will always only be just one element. Okay, then we can confirm inside this button. There's nothing to choose. Run text editor, and we can just run it. Okay, previously we had a status bar, now we also have it. We now also have a file menu. Previously we did not have this thing, a quit action. The rest of the main menu is the same. Okay, so this did not work because text editor UI RC failed. Let's see where that thing is. Text editor UI RC. Let's look a bit at the structure. top level should be a text editor UI RC, and there is. Then in cmakelist.txt there should be a install inside the destination ktext editor. What do you mean install? We're not running the install step. So let's build using kde-builder and see what it tries to do. So kde-builder KXmlGui tutorial. And inside the destination there should be this text editor thing. And now we should probably be able to run the application. Okay, so this RC file is actually not processed by RCC executable, not in the QRC format. It's just a XML file. It's not being even included as a resource in the generated text editor executable. It's just a simple plain text file that we're copying to tilde/kd/usr directory somewhere in there. Who knows where? Let's see how we find it. So tilde-kd/usr, and we can open it with Visual Studio Code and search for a part of the file. Okay, so the file has been copied to tilde/kd/usr/share/kxmlgui5/texteditor/texteditorui.rc. Let's see where in the source code we actually use this file. texteditorui.rc, and doesn't say anything else. What does setup GUI do? KXmlGui window. So maybe this has a default search path, which includes /share usr KXmlGui5. But then how does it know about text editor? It's a component. So text editor is a component and text editor UI RC is a file. Okay, so this doesn't run correctly from Qt Creator because we're not setting an environment variable. And I would not know what that environment variable is. Let's see if I can fix this thing real quick. So in the file tilde/kd/build/kxmlGui tutorial prefix.sh, the only thing that might be is this guy. Let's set just this environment variable and see if it's enough. We need a text editor. Ctrl-Shift-T, Ctrl-Shift-V. This thing. So this is a bash expression, and this thing is going to be expanded. So this is a string kept as is, but then this is evaluated by bash, and the result is being replaced in here. So the environment variable kde-builder doesn't have this value, it actually has this value. And then I have created a pair with kde-builder, the name of the variable, equals, and then the actual value of the environment variable. And this pair I will need to paste inside Qt Creator. So let's see exactly how that works. So the procedure for Qt Creator, and we want to set the environment variables in order to run. So this thing, we can set all of the environment variables at once, and that's totally recommended. Or in this case, I'm just trying to be clever and put just one environment variable to see if that's the source of the issue. That's how the full path to text editor UI.rc for component text editor is being computed. Okay, Qt Creator projects, switch to projects mode, Ctrl+5. Show me the tooltip. This guy. Build and then run. Run settings. Select text editor, that's the only option from the combo box. Environment group box, this guy. Expand details, this button. To the right of the button append path, so this is the button append path. This is to the right of it. There's an empty multi-line edit box, paste. Okay, we can enable this checkbox to show the values of all environment variables before actually starting the process named text editor. Okay, and now we can just run. And this time it worked correctly. And let's see the variable that we have actually set. So kde-builder, this guy, and it has exactly the value that we have provided. Starts with tilde/kd/usr/share, ends with snapped desktop. Okay. And now we can clear it like this. Another menu, clear. Clear. Okay, now we have a toolbar. So status bar came with KXmlGui without any .ui XML configuration file for KXmlGui library. But the toolbar required a RC file, the XML file that configures KXmlGui. Now we have a toolbar which we can show or hide, and we can edit the toolbar. We can make the toolbar not be locked, so we can make it vertical, horizontal, vertical to the right, horizontal to the bottom, floating. We can we can change the size of elements. We can put the text below. We can add more buttons. We can put the main toolbar back to where it was. Make it floating again. Make it sit on top of the title bar. And it works as we expect, in the sense that it's a modal that we would expect. No model. It's sitting on top. So we can use the rest of the application, but only when needed we are going to click on the button. The coloring is a bit strange. This is dark gray, this is light gray, and this is both. Lock the positions. No documentation yet. So this is product manuals, which means a docbook file installed locally, or if not, a web page URL. Okay. So we managed to implement all of these. Let's see how that works. And then saving and loading is going to be very simple changes. Command line interface. Okay, we're going to just read the code and understand the code, and then that's going to be it. So let's go from the start. We have a file cmakelist.txt. Most of this file comes straight from the Hello World application that only showed a message box using a KDE library. So CMake minimum required version, the project name changed 3 times. First it was Hello World, then main window, now it's text editor. A minimum required versions for Qt and KDE Frameworks. We're using ECM, which is very foundational library from the KDE Frameworks. Not even sure if it depends on Qt, this ECM thing, which then provides us KDE install dirs, KDE CMake settings, etc. KDE CMake settings.cmake. It's included as a module inside the top level CMake list.txt. We only have one CMake file, just the top level CMake list.txt. Okay. Feature summary comes from, it's a first party library, comes straight from CMake, from /usr. The KDE things come from ECM, ~KDE/usr/share/ECM. Okay, then it's finding packages, separate finds for the Qt modules, separate finds for the KDE frameworks. We don't generate any libraries, just a executable. All of the files except the .rc file, which we should probably add here. Then we want after the .o files are built to link all of those together and generate the executable, but that will require additional libraries, so additional command line parameters for the linker. We need Qt Widgets and other Qt modules, and KConfig widgets and other KDE frameworks. The make install step, the Ninja install step, will copy the text editor from tilde/kde/build/KXmlGui minus tutorial/bin/k/text editor to tilde/kd/usr/bin, which is this directory. And then the file text editor UI.rc is not included as a resource inside the executable, but instead is being copied to a path where KXmlGui, the KDE framework, knows how to find it. And then we have this important feature from CMake, which shows that summary with modules that are found and optional modules that are found and required, etc. And then for CPP files, a main, which is the same as we know, a key about data, a Q application, make the internationalization work, set application domain for key localized string, Qt literals, string literals for U, and then literal string, and then _s. We use a command line parser, make the command line parser see about data and see Q application. So these three things communicate correctly. And then this is the usual way that you start a main window of an application. This is the main loop of Qt. This is an infinite loop that waits for events, for a mouse click, for a mouse move, or a keyboard press, etc. And then acts accordingly. It depending on which events have implementation, we'll call those event implementations. So event-based programming. In here, we're creating a C++ class, and we're calling the method show. This C++ class inherits from QWidget, because QWidget provides the public method show, which is actually a slot. Let's look through main window. So main window is split between a .h file and a CPP file. In the .h file, we see the definition of the class, and we have a private method setup actions, and then the rest is of the source code is in main window.cpp and inside the qrc file. First, let's look at the qrc file. File save all. This file text editor UI.rc. So this is an XML format that's understood by KXmlGui, the KDE framework, and says that when the application starts, it should have a menu bar with an element named file, a sub-element, a sub-menu named with the element clear. So there's a file clear element now, which did not exist before. Before there was just file quit created automatically by default by KXmlGui. Now we in code custom have added this action under file clear, under another menu clear, and also as the main toolbar action clear. Okay, the action is defined somewhere else, but then this file says where the action should be surfaced. Should be surfaced in the main menu file, in main menu another menu, and in the main toolbar. Once you change the look of the toolbar, you can also save that change. So let's see how that works. Now we see the version of the main menu of the main toolbar that's configured in here in text editor UI.rc, this, plus all of the changes that we did using the mouse. So we made the icons largest possible. We put the text below the icon, not beside, not at the right of the icon. And then we have added two other actions to the main toolbar. And then this new configuration is saved as XML in a format similar to this one, with many toolbar XML elements in here. And it's not going to be saved in tilde/usr because that's per system and that's read-only, because we're not a user root, so we cannot actually write to /usr. So these settings are being persisted per my user in my home directory, probably in tilde/.config. That's a functionality provided built-in by KXmlGui. The fact that it knows how to save the settings that the user changes in the configuration of the main toolbar. Okay, and then to the main window.cpp file. All of these come once you use symbols from these header files. This part has stayed the same inside the constructor of the main window. We create a KTextEdit instance and we make it doc fill, or take the entire central widget. Okay, the entire body of the application is covered by a text area, or is actually the text area because we're actually assigning the text area to the central widget. Okay, and then let's see what we do. The most important thing that we want to do is to have the action that we're using everywhere. So the action named clear, which we use in 3 places, 1, 2, and 3, needs to be defined. So the text clear lowercase should exist, this thing, add action, and then that should have the icon. The icon is the document new symbolic from the theme, which makes the icon not have colors, just black and white. Okay. I'm not sure what action collection is. So action collection is a public method of KXmlGui client, which means we are inside this. Okay, so there's a collection of actions which might contain all of the actions that are displayed by default by KXmlGui, such as the help about application and help about KDE. So this action about KDE and about main window and donate, etc. and then it's adding another action to them. The action is named clear or lowercase with this action, which, as we saw, has an icon, text, tooltip, was this, etc. We did this. Now it's available inside the toolbar editor, inside here. And Control L is the default keyboard shortcut shown in here. Clear Control L in the main menu file, in the main menu another menu, in the tooltip. So the tooltip says, where is the tooltip? I don't know where the tooltip is defined, but the text is clear with accelerator. Press the Alt key. So it's set the keyboard combination Control L, and then this action doesn't actually do anything. Has the correct icon, has the correct text, has the shortcut, can be actioned by accelerator, so Alt C, but it actually doesn't do anything. And now we're doing a Qt connect signal slot where the already defined slot clear is being executed, performed when the triggered of clear action, triggered signal is triggered. So a slot and a signal. So a signal is an event being triggered. It just says a button has been pressed, or in this case, the user has clicked on the main toolbar on the button clear. And then this is a method with body implementation in a CPP file, qtextstate.cpp probably, that actually clears the content of a QTextEdit, which is probably the multi-line text editor in control in Qt. And that's what it is. So KTextEdit clear is actually QTextEdit clear. I don't know. Text edit. Okay, where is clear? Okay, so there's no clear in here. So I'm going to guess that this can be replaced with the actual type of the clear. Like this. Okay, and then for Qcore application quit, key standard action quit, action collection. Let's see what this thing does. Quit the program. The only explanation that I have in here, I don't really know what's happening. I guess that this takes the pre-existing action collection that exists in KXmlGui client, that contains the elements file, quit, settings, show toolbar, show status bar, configure language shortcuts, configure toolbar, and everything in here. To that action list, action collection, it adds clear, and line 27 adds another standard KDE action, which is called quit, which quits the application, which has the standard KDE icon and the standard KDX translated text, accelerator, everything. Tooltip. And then that's made available in the file quit button. Main menu, file, quit, Ctrl Q. Okay, and setup GUI is from KXmlGui window, which, so RC is actually a file about the settings that the user wants for the main menu and for the main toolbar. Setup GUI default. What is this default? So this is an optional parameter, and this is the XML file. Let's see what this thing actually does. KXmlGui. KXmlGui. Okay, KXmlGui, Visual Studio Code, and this guy. KXmlGui window.cpp. Standard options default, and then XML file, which goes to the next one with 3 parameters: queue size, options, and XML file. Works on the status bar, on the toolbars, on the keys. The option is the default, which default is toolbar, keys, status bar, save, create. So all of these are exercised. Set autosave settings. Okay, and yeah, it parses that XML and does things accordingly. So if the user has already changed the settings and settings exist in the tilde/.local tilde/.config directory, then those settings will need to override the settings that exist in /usr/in usr/share. There needs to be an overlay created out of those two, etc., etc. And then the XML be parsed. Okay, so this is it. This is how to follow the tutorial on how to use the most elementary KDE frameworks for creating graphical user interface applications that use Qt widgets. So if you're creating a KDE application, that's graphical user interface application, and uses Qt widgets, then you're probably going to use KXmlGui for creating the main menu, the status bar, actions, main toolbar for letting the user edit in a uniform way across all of the KDE applications that use Qt widgets, the main toolbar for making the toolbars floating, etc. For using the same icons, standard shortcuts, etc. for various actions. So you want your application to be as well integrated into KDE as possible. And if all of the applications use Ctrl Q to exit the application, not only Alt F4, then also your application must use that. And you get that for free by just using the KXmlGui KDE framework. Okay, we started by using a message box. We added internationalization. So one by one, we keep adding the KDE frameworks. We start with just the framework, the KDE framework that provides KMessageBox. We continue with K-internationalization, K-about-data. We keep making the cmake-list.txt file more complex. We add KXmlGui window, which provides a ton of default actions and main menu and status bar, and the main control where we place a KTextEdit which inherits from QTextEdit. So it's an enhanced version of the Qt control QTextEdit. Okay, what else do? We start the main loop for the first time, the Qt main loop. So this will run forever until you close the application. You can close it with Ctrl Q, Alt F4, right click in the task manager, etc. Kill the process. Okay, in CMake list we keep renaming the executable that we are going to generate. Then we're adding our custom action named clear with this icon for new document. And we're hooking this action with QTextEdit clear. Slot or signal. Let's see. So we connect clear action triggered with text area QTextEdit clear, which is a slot. So a slot has implementation. Body inside the CPP file. Okay. And not only that, but the user is able to edit the main toolbar because a main toolbar starts to exist. At the previous step, the main toolbar doesn't exist at all. It adds two actions in the file main menu, one using the XML that's understood by KXmlGui, another one we edit programmatically in here using KStandard action : quit. Okay, the source code is again pretty self-explanatory. It's not clear why would you create a Q action first and then add the Q action to the action collection. So the order of operations is not evident, but you definitely can read the source code. It's readable. Okay, then it adds way more actions: new, open, save, save as, and maybe cut, copy, paste. Clear action, Control W. Okay, standard action. Okay, the XML that says that a menu bar should exist, and then that says that a toolbar should exist, should be named main toolbar, and file clear should exist. Okay. And then this RC file will need to be found by KXmlGui at runtime. If you're not placing this file in a correct directory where KXmlGui knows where to search for, you will the application will run, but at standard output you will get an error saying that KXmlGui cannot find texteditor UI.rc from module texteditor. Okay, so more actions are being added, made available by default in the toolbar. You can also create a separator, also made available in the file menu. So new file, open file, save file as a file name. It's important that you run this tutorial yourself, do all of the things that I did, use a text editor, use a build framework such as KDE Builder, or maybe you're building everything from scratch using CMake yourself. Use a debugger, use a text editor or integrated development environment that knows how to navigate source code, etc. Because using Q_object is bread and butter in Qt. Using Q slots is bread and butter, etc. So you will do these things over and over, and it's important that you train your hand on all of this entry-level source code. Okay, it's not using the .rc file, it's actually using KStandard open, KStandard actions, open, save, save as, open new, and then it's adding, it's implementing all of these with the slots. So new file does something to file name and text area, which are the only two member variables of the current class of this. Save to disk, no, save file as, triggers the file save standard dialog, gets a full path, and then sends that full path to a private method. Save file, if we already know the name of the file because the file save as dialog has been run once, then don't run file save dialog again. That's what save is compared to save as. So save as always triggers the save as dialog. Save triggers the save as dialog once. Open triggers the other dialog, not the save dialog, but the file open dialog. Local file. So it says URL, but it's about local files. It doesn't go on over the internet. Okay, there's explanations for every single line that has been changed or added. We need KIO for doing asynchronous file operations. And let's look at the next part, command line interface. We already have command line interface because we're using the K about data, Q application, and Q command line parser, and they know, all three know of each other. Now it's going to add another command line parameter, which will exercise Q command line parser. So it says parser add positional argument file, which means -f, -- file. There's documentation for this command line parameter, because if you run with the command line parameter --help, it will say a bit of text about -- file. And maybe it will also accept -f. Okay, then after the user provides the command line parameter, for instance, it's the command line is text./texteditor space -- file space tilde/a.txt. Positional arguments count is greater than 0, and positional arguments first one, so position 0, is the full path, so relative path, tilde/a.txt that we provided at the command line. And then we're calling the private method that we just have extracted, named open file from URL, which is called twice. Once from the command line, and the other time from the open file action implementation. Okay, so it doesn't even require -- file, it's just test file. That's interesting. And that's about it for the tutorial. Thank you for following along. I hope you program for the KDE community. Thank you.